Okay, this is lesson 4.4. We are going to be discussing the chain rule. The chain rule is a very, 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 very important rule for taking derivatives. You have to know the chain rule for the rest of calculus. It's possibly the most important rule you're going to learn this year. So pay attention, be alert, listen. When we use the chain rule, it's going to be the method for taking derivatives in which you have two functions. We're going to say one is the inside function and one is the outside function. Technically, these are composite functions. And so, for example, we have f of x equals square root of x. You know how to take the derivative of that right now. That's x to the 1/2 power. G of x, which is x squared plus 1 here. You also know how to take the derivative of g of x. That's g prime would be 2x. What the chain rule will teach you is how to take the derivative of f of g of x when you not only have the square root of x, but you have the square root of x squared plus 1, where your inside is not a simple x, but rather it's some other function. In order to do the chain rule, you have to be really good at determining what the outside function is and what the inside function is. And so I'm going to use this language a lot. I'm going to say, what's the outside? What's the inside? And so let's go ahead and talk about how to take the derivative of the square root of x squared plus 1. So right down here, I have written the chain rule. This is technically the technical definition of the chain rule, how you are to take the derivative of a composite function. And then down here, I have in quotation marks, how I'm going to verbalize what the chain rule is every time I do it. And so what the chain rule is that you have a composite function. You have an inside, which is g of x, and an outside, which is f of x. Inside g of x, outside f of x. The way this works is you do the derivative of the outside first, and you leave the inside alone. Inside stays there. Then at the end, you multiply by the derivative of the inside. So it's the derivative of the outside, keeping the inside the same, then multiplying by the derivative of the inside. And so the chain is that the inside is linked. You keep the inside the same, and then you multiply by the derivative of it. Okay, so let's go up to this example right here. Square root of x squared plus 1. We're going to rewrite this as x squared plus 1 to the 1/2 power, because I know how to do the derivative of 1/2 powers. The outside function here is 1/2 power. It's to the 1/2 power. And so when I do the derivative, I do the derivative of the outside part first, which would mean I do a 1/2 to the negative 1/2. Normally, we do that with an x. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. Here, however, I have 1/2, and my inside is x squared plus 1. That will now be to the negative 1/2. So notice that my inside did not change. It is still x squared plus 1. I know x squared plus 1 has a derivative, and that the derivative is 2x, and you multiply by that at the end. So this would be the derivative of f of g of x. Okay, the whole rest of the time in this lesson, we're going to be doing examples. Okay, I'm going to keep my outside in blue again. So in this first example, number 1 here, y is 5x minus 3x squared to the 5th power. So one way of knowing what the outside function is the outside function is the operation you would perform last if you were plugging in a number. It's also the operation you would get rid of first if you were solving for x. So the outside here is to the 5th power, whereas the inside is the 5x minus 3x squared. So this is my inside, and my outside is to the 5th power. So when I do y prime, I'm going to do the outside derivative first. So the derivative of a fifth power is 5x to the fourth. Only I don't have x. I have an inside of 5x minus 3x squared. So it's almost as though you're putting on like blinders. So it's almost as though we're putting on a blinder. I'm going to cover up my inside function. Oh, I should have made this green. So I don't see it. So it's something to the fifth. Then my derivative is 5 times that thing to the fourth. And now I uncover the inside and I say, oh, look at that inside. There's a derivative there. The derivative is 5 minus 6x. That gets multiplied at the end. All right, let's move on to this second example, number 2. And number 2, just like with what we've learned so far, when we have roots, we need to rewrite those. So this is 1 plus x squared. The cube root means I have a 1/3 power. So that was squared, and now it's to a 1/3 power. When you have a power to a power, those powers multiply. So this is 1 plus x squared to the 2/3 power. I've done no derivative, no calculus yet. I am simply rewriting my original question so that it's easier to take the derivative of. Okay, who is the outside function? Well, the outside function is the 2/3 power. And so the derivative of something to the 2/3 power is 2/3 to the negative 1/3. Because 2/3 minus 1 is 2/3 minus 3/3, so negative 1/3. And then the inside was 1 plus x squared. Oh, I did my color. I switched my colors. Sorry. I meant to keep the outside blue. Well, now my inside's blue. So 1 plus x squared, and now I multiply by the derivative of the inside, 2x. And you can simplify this. This will be y prime equals 4x over 3 times the cube root of 1 plus x squared. So how did I simplify that so fast? Well, in the top, I have a 2, and I have a 2x, right, because it's over 1. So it's 4x in the top. I know I have this 3 in the bottom. There he is. And then a 1 plus x squared is to a negative power. Negative powers go to the denominator. And a 1/3, I just rewrote that as a cube in the denominator because it was a negative to start with. All right, now here's number 3. I want you to do number 3 on your own. So I'm going to be looking to see that you got that accomplished. Number 4, you can't do number 4. You don't know the derivative of tangent yet. We'll save that. Number 5. Okay, here I have a quotient. To do the derivative of a quotient, I have to use the quotient rule. You cannot forget the quotient rule. We're going to still use it. So I'm going to label my numerator as f and my denominator as g. And I'm going to find f prime and g prime, just like we've always done with the quotient rule. Well, what's the derivative of g? That's simple, 1/2 x to the negative 1/2. What's the derivative of f? Well, the f has is a composite function. We have an outside and an inside. Okay, I'm going to go back to the outside being blue. The outside would be to the 4th power. So the derivative of something to the 4th power is 4 times that thing to the 3rd power. When that thing is a complicated thing, like this polynomial 3x squared plus 5x minus 1, you need to keep that in there, do the derivative of the power around it, then multiply by the derivative of it, of the inside part. The inside part has a derivative of 6x plus 5. I'm going to put that in parentheses and multiply by that at the end. Okay, and now let's finish up my quotient rule. So the derivative of my original function g of x is f prime g minus f g prime divided by g squared. And I just need to fill in from my chart up there that I made. So f prime, that's 4, 3x squared plus 5x minus 1 to the 3rd. Let's have 5. So that's f prime. That was what we needed the chain rule on. Now multiply that by g, x to the 1/2, minus f, 3x squared plus 5x minus 1 to the 4th times g prime 1/2 x to the negative 1/2 divided by g squared. G is the square root of x, g squared would be x. Now I'm gonna simplify this for you. This is a college calculus requirement that you can simplify these quotient rules, especially when you use the chain rule like this. So we're going to factor out, before I distribute or collect like terms, I'm going to factor out like terms, like products. Notice this 3x squared plus 5x minus 1. I have one of them here. Actually, I have 3 of them here, don't I? And then I have 4 of them here. So I know I can factor out 3 of them. So that's the first thing I'm going to do. I'm going to factor out 3x squared plus 5x minus 1 to the 3rd power. Also, we've already done this a little bit, but I'm going to see this x. I have an x in both products. One is to the 1/2, and the other one is to the negative 1/2. So I'm going to factor out the one with the smaller degree. That would be a negative 1/2. Okay, and let's see what we have left. In the first term here, I have a 4. I took all of this green 3x squared plus 5x minus 1. I took all 3 of those out. Then I have a 6x plus 5 left. And this x to the 1/2 here in purple, let me go back to purple. I factored out negative 1/2 of those. So when you factor out, that's the same as dividing. When you divide two quantities that have the same base, then you subtract their exponents. And so left here, I had a 1/2. I divided out a negative 1/2. So I have 1/2 minus negative 1/2 left. 1/2 minus negative 1/2 is 1/2 plus 1/2, which is 1. So that's just an x. So that's my first term up there. That was the f prime g. Now it's minus fg prime. In the green, this 3x squared plus 5x minus 1, I only took out 3 of those. So I still have 1 left. And then I still have that 1/2, and I took out the entire x to the negative 1/2. This is all over x, and then I'm going to do some algebra here and clean this up just a little bit more. Okay, now one thing I'm going to do is I'm going to take this purple x to the negative 1/2 here, and I'm going to make that positive x to the 1/2 in the denominator. And there's already an x down here, so when I multiply those together, I add the exponents, and 1/2 and 1 is 3/2. And so on the bottom, you'll see x to the 3/2. Then I have the green 3x squared plus 5x minus 1 to the 3rd. I'm not going to do anything to that. So I've taken care of this. I've taken care of this. Now I have what's in the parentheses. Let's distribute this 4x. That would give me 24x squared plus 20x. And then let's go ahead and distribute this minus and the 1/2. So that's minus 3/2 x squared minus 5/2 x plus 1/2. And finally, I'm going to go ahead and collect like terms in that bracket, and you will be all done, and you will be able to simplify properly the way the big kids do on college campuses, and the way that you can do it. Okay, so 24x squared minus 3/2, that's 48 halves. So 45 halves x squared. I should have factored out that half. Oh well. Plus 20 is 40 halves, 35 halves, x plus 1/2. All divided by x to the 3/2. This is as simple as it gets. Okay. I have a few more examples. What number am I on? Number 6. Number 6 here is another product rule. I'm going to leave this one for you, so you can do this one. F is x cubed, g is x minus 1 to the 1/2. This is where you would use your chain rule, is in the derivative of g. Now I'm going to do this number 7 with you, because this is a chain rule first. Well, it depends on how you look at it. It could be a chain rule first and then a quotient rule second. I'm going to show it to you that way. So when I look at this, I see an outside of something to the 3rd power. Am I doing outside in blue? Yes. Something to the 3rd power. And so when I take the derivative of f, I want to do the outside part first. 3 squared. The only problem is that my inside is not very pretty. It is a quotient. And so when I multiply by the derivative of the inside, well, the inside is a quotient. And when I take the derivative of the quotient, I have to use the quotient rule. And so on the inside, I'm gonna just do some side work here and label my inside as y. And I'm gonna pretend like I am from last week, and I am doing the derivative of this equation here, this y function. So I'm going to label the top as f and the bottom as g. And do the derivative of the top and the derivative of the bottom. And now use my quotient rule, f prime g minus fg prime over g squared. And so that derivative of that inside function, which I've called y, is 2x plus 2 minus 2x minus 1 times 1 all over x plus 2 squared. And I will just collect like terms on top. That's 2x plus 4 minus 2x. Well, 2x minus 2x, that cancels. 4 minus negative 1 is 5. So that's the derivative of the inside. That's what gets multiplied right here. And we're done. Okay, not with the whole lesson. Okay, here's one of these graphing ones. I have given you two graphs of functions f and g. F is in green, g is in purple. And I want you to compute the following derivatives. So if you need to do 2 times f of x, this is a constant multiple rule. So that would be 2 times the derivative of f in order to do that derivative. And then I need to do this at 2. So what is 2 times f prime of 2? Well, that would be 2 times whatever the slope of the graph is at 2. The slope of the graph of f at 2. So, oh, that doesn't exist. Right? F is in green. At x equals 2, I have a corner. And there's no slope there. I mean, maybe it's negative 2, maybe it's positive 1, because that's the graph on either side. But it's not the same on both sides. So this actually does not exist. Does not exist. Let's do f minus g at 3. That would be f prime minus g prime, and then you plug in 3. So the slope of f at 3 minus the slope of g at 3. So let's go back up to our graph and let's look at what's happening. Get this. At 3, f doesn't have a derivative. So this does not exist. Also, I think I meant to switch those. Let's change this one to at x equals, well, I can't do 2. Let's do at x equals 1. That will work. Let's do this at x equals 1. So here I have a product, f times g. So I need to use the product rule when I take the derivative. So the derivative of f times g is f prime g plus fg prime. I'm doing this at 1. So I'm going to replace x with 1. And f prime of 1, I need to know the slope of the graph of the green at 1. That's a slope of negative, I don't know, down 1, 2, 3, 4, 5, over 2. So it's a slope of negative 5 halves. And then at 1 for g, the slope is Well, down 1 over 1, 2, 3, 4, 5, negative 1/5. And f of 1 and g of 1 are both 4. You can read that right on the graph. So this is going to be 4, 4. This was negative 1/5. This was negative 5/2. And do I connect these? Okay. So that's negative 10 minus 4/5. So it's negative 54/5. On this one here, you would use the quotient rule. I'll let you do that one. But I wanted to point out here we have the chain rule. So here I need to do the derivative of the outside and then multiply by the derivative of the inside. So if I go ahead and do, did g exist at 2? At x equals 2, yes, no, it didn't. Neither of them exists at 2. Let's do this at x equals 4. And I will replace x with 4. And I have to find out what g of 4 is and what g prime of 4 is. So if you look at this graph, here's where x equals 4. G is the, well, I can't do g. Let's not do 4. G is the purple one, right? Choose the purple one. So I can do g of 1, 2, 3. We'll do g of 3. Making x 3. All right, so what is g of 3 and what is g prime of 3? I'm quitting after this one. G of 3 would be the purple graph at 3, so it looks like the y value there is 1, 2, 3, 4, 5. G of 3 equals 5. And what's the slope at 3? Up 1 over 1. So the slope is 1. So G of 3 is 5 and G prime of 3 is 1. So this means I have f prime of 5 times 1. And what is f prime of 5? So go back to the graph, look at where x equals 5. 2, 3, 4, 5. What is the slope of f there? F has a slope of 0 there. So 0 times 1, 0. And the way that we do the rest of these is to use the chain rule. Let me just jump to this last one right here with the square root. This is f squared plus g squared to the 1/2 power. And so if I were to take the derivative of this function, then I do the derivative of the outside first. Keep the inside the same. Now, don't forget to do your power rule. So 1/2 to the negative 1/2. Now multiply by the derivative of the inside. Well, the inside is really weird. Let me call that, I don't know, z. F squared plus g squared. Well, the derivative of f squared would be 2 times f, but f itself has a derivative. That would be f prime. So this is a like triple chain rule. Now plus the derivative of g squared is 2 times g to the first power, and then multiply by the derivative of the inside. The inside is g. G has a derivative. It is g prime. So this would be times 2f of x, f prime of x, plus 2g of x, g prime of x. And then you would plug in 2 and read from the graph. Only I don't exist at 2, so not going to do that. Last question. Find the equation of the tangent line. And this is, of course, my favorite question. So y minus y1 equals m times x minus x1, y minus 4, m, x minus 1. I just have to worry about m. M will be f prime of 1. So f is 9 minus x squared to the 2/3. I can find f prime by doing the derivative. I do the 2/3 power first, keep the inside the same, multiply by the derivative of the inside. Now plug in 1. So if I plug 1 in, I get 2/3, 9 minus 1, that's 8 to the negative 1/3 times negative 2 times 1. So this is 2/3 times 1 over the cube root of 8 times negative 2. The cube root of 8 is 2, so this is negative 4/3. And then let's go back to our line. Just replace m with negative 4/3. And we're done. All right. Have a good week.